Hello everyone, this is KP the Math G. I have decided to do a second video of the same day. I usually try to just do one a day, but my wife is sleeping now, and I thought this would be a good opportunity while she is sleeping to do a video. I'm in another room to myself, so I'm not going to be disturbing her. But anyway, it's very good to be able to talk about calculus. And in this particular case, the calculus we're doing is we're trying to find, I don't have it written up here, but this is part 3 of the definite integral. And remember, we said the definite integral is from a specific number to another number. And for those who have not tuned in, the definite integral is actually the second fundamental theorem of the calculus, which says that if I integrate from a to b f at x dx, then the answer to that is capital F at b minus capital F at a. And that's really what the second fundamental theorem of the calculus is. Or whether you want to call that the first one or the second one, does not really matter. Just understand this is the antiderivative here. Alright, and then you're substituting the numbers inside there in that order, always with a minus sign in the middle. Okay, so that is all I wanted to say about that. Okay. I want to show two ways. I hope that my video camera cut me off last time on the last video, so I apologize for that, but hopefully I won't get cut off this time. But if I go too far beyond 30 minutes, I'll get cut off again. So anyway, alright, now I want to rewrite this, of course, alright, like this, from 1 to 4. I actually want to go from 0 to, I think I changed it to from 0 to 1. Okay, yeah, from 0 to 1. I had 1 to 4, and 1 to 4 will work fine. I mean, I could leave it like that, but I do believe that I have made it from 0 to 1. Yes, it is. Okay, and that'll work also. Okay, anyway, I want to write this to the 1/2. By now, you should know that on a square root, the power over the index is 1 over 2. If it's just a square root like that, x dx. Okay, so how do we do this? We do have to have u substitution. I have something raised to a power. This exponent happens to be 1 greater than that. That's going to work out just fine. Alright, so let's do that. I'm going to let u be equal to 3x squared plus 1. And so du is equal to 3, 2 times 3 is 6x dx. I've got x dx. I don't have 6x dx, so I need to multiply by 1/6 both sides. Alright, so see, that gets rid of my 6's there. Okay, so this is 1/6 du is equal to x dx. Alright, so I want to put 1/6 right here, and integrating from 0 to 1. Alright, now one method is that you leave the numbers that you integrate with, you don't do anything with them. Okay, alright, so let's see what we get here. This is u. U is this to the 1/2 and du. Du is x dx. Okay, we got that. Alright, now I know how to integrate this. This is 1/6. I am going from, I'm not plugging it into here, but I'm still going from 0 to 1. And when I integrate, I don't use this anymore. So this is u. Now remember, u to the 1/2 plus 1, which is 2/2, is u to the 3/2 over 3/2, which, by the way, I just flipped this up. Okay, I just flipped this up. So this is u to the 3/2 raised, and then put 2/3 right here. Whatever you raise this to, just flip it over. Alright, so in this particular case, let me erase this. This is going to be u to the 3/2, and then 2/3 goes right here. Okay, like that. Alright, I want to erase some of this. I appreciate everyone tuning in. I appreciate you being patient with me, because a lot of times, you know, with this little old board I've got here, I don't have a lot of room, and you are patient with me, very patient. Alright, so now I can go ahead and multiply this, 1/6 times 2/3. So I can do 1/6 times 2/3. And now I have u, but u is 3x squared plus 1. So 3x squared plus 1. And that is to the 3/2. 3/2. And I'm still going from 0 to 1. Like that. If I multiply this out, I believe I'm going to get 1/9. 2 goes into 2 one time. 2 goes into 6 3 times. 1 times 1 is 1. 3 times 3 is 9. Alright, now I can start substituting this in. So this is, by the way, this is going to be the square root of 3, alright, x squared plus 1, and then minus the square root of 3x squared plus 1. And the first time I'm going to plug in the 1, and the second time I'm going to plug in the 0. If I look at this, this is 1/9. Oh, by the way, I do have a 3/2, not square root, but I still got to raise this to the 3rd power, don't I? And I still got to raise this one to the 3rd power as well. Alright, so Jiminy Cricket, don't forget that one. Okay. Alright, now that's how you write the. Alright, so if I had a to the 3/2, that's the same thing as saying the square root of a cubed, like that. Okay, that's what I'm saying here. Okay, alright. Okay, so there that is, right there. Alright, this is method 1 of this, so we're going to do another method. Alright, so 1 squared is 1, 3 times 1 is 3, plus 1 is 4, square root of 4 cubed, minus, okay, 0 squared is 0, 0 times 3 is 0, 0 plus 1 is 1, the square root of 1 cubed. Alright, so this is equal to 1/9. Okay, the square root of 4 is 2, so that's 2 cubed, minus the square root of 1 is 1, so 1 cubed. See that, everyone? And now that's 1/9. Alright, 2 cubed is 2 times 2 is 4. 4 times 2 is 8, so 8 minus 1 is 7, so 1/8, 1/9 rather. 1/9 times 7, and this is actually 7 over 1, so 7 over 9. And this may be how much water you have in a tank, or how much have you filled it up. It's 7/9 full. Okay, it's a weird answer, but yes, that's what it is. Okay, or it could be that. It could be anything really that has to do with amount. And so anyway, All right, that's that way here. The answer is 7/9. Now, here we did not change our limits of integration. We did not change those. Okay, we just left them as is. After we integrated and got U, we plugged that back in. This was the way I was taught it a long time ago, and I was taught very well. This was fine here. This is all good, and you're going to get 7/9. If you like this method, okay, it's fine. I'm going to do something a little different than the last one, so I'm going to have to flip it over and put the problem back up again. Square root of 3x squared plus 1. And here we go. So now again, we'll evaluate from 0 to 1 the square root of 3x squared plus 1 x dx. I do believe that's what I had originally wrote down. Yes, I do. Okay. Again, you're going to do this. You're going to let U get a different color. I like a variety. So here we go. We're going to let U be equal to 3x squared plus 1. I'm going to leave that up there. Now, I still want to do du. I always like to do du first. This is still 6. 3 times 2 is 6, or 2 times 3 is 6. X dx. Okay. And then I'm going to multiply by 1/6 on both sides. Times 1/6. So 1/6 du is equal to x dx. Did I do that on the other side? Yes, I did. 1/6 du is equal to x dx. Same thing. That does not change. Okay? I'm trying to compare, and I hate that I have to flip back and forth, but I'm at least glad that I'm able to flip it over. So instead of just have a one-sided board. Okay, here we go. We're going to go back. So that's the same thing. So what's different, KP? Alright, now here, U. U is 3x squared plus 1. Going back to this. Okay, now remember, I'm going to put this 1/6, and I'm going to integrate, but this time I'm going to change my limits of integration. And there's a reason for it. It makes life a little simpler, I think. Okay, there it is. Now, here's how to do it. You take the highest level, alright, the upper level, alright, 1 squared plus 1. 1 squared is 1. 3 times 1 is 3. 3 plus 1 is 4. So instead of a 1 here, I'm going to have a 4 here. Okay? Let's do it again with the 0 this time. 3 times 0 squared plus 1. 0 squared is 0. 3 times 0 is 0. Alright, so 0 plus 1 is equal to 1. Alright, so I have a 1 here. Now, if you look at the difference, I had a 0 on the bottom and a 1 on top, but this time I have a 4 on top and a 1 on the bottom. That changes. That's what I'm saying. So here's how you just remember, don't panic. U is equal to 3x squared plus 1. Du still the same way. I got it all set up. And again, this is U to the 1/2 du. We still got all of that. Okay, same thing, except what we did, we changed our limits of integration. Okay, Alright, so now we're doing it this way. And instead of substituting u back in, we're going to leave it in terms of u. And you still get the same answer. Okay, so 1/6. We're integrating from 1 to 4. Alright, so this is now still u. Remember we added 2 halves. That's still u to the 3 halves. Okay, u to the 3 halves over 3 halves. So remember that we did the 2/3 right here like this. Remember that? 3 halves. That does not change, except we're going from 1 to 4 this time. Again, look at the same thing. We got the exact same thing right here. That does not change here. Alright? But remember, we substituted this back into u and then plugged in the 1 and the 0. That remained the same, didn't it? Alright? You see the difference in the two? But this time, since we have changed that, we're going to leave it in terms of u. Alright? So 1/6 times 2/3. Alright, now again, the square root of u cubed. Alright, I'm going to put my 1 up here. Okay. Square root of u cubed, like that. Again, 2 goes into 1 time, 2 goes into 6 3 times, 1 times 1, 3 times 3, so that's equal to, put it up here, alright, so that's equal to 1/9 times, alright, now, the square root of 4 cubed minus, always a minus sign, the square root of 1 cubed. A little tight squeeze, isn't it? Alright, let me erase this so you can see that. You don't need that anymore. Kind of make it a little where we can have a little room here. Excuse me, I'm sorry. This is the square root of 1 cubed here. Alright. You cannot forget that cube on there. Alright, so that's equal to 1/9. The square root of 4 is 2, and that's 2 cubed. Square root of 1 is 1 cubed. 2 cubed is 8. 2 times 2 is 4, times 2 is 8. Hope you get where you can just do that without thinking. 1 cubed is 1. Don't think about that one. Alright, again, this is equal to 1/9 times 7, which, by the way, is equal to 7/9. Okay. Do you see the difference? Okay. On the first one, on the first set that we did, let's look back over it again. We still did use substitution, just like we always did right here. And then, of course, everything that follows is right here, 1/6. Okay. Du is equal to x dx. That's what we had here. We kept the u down to that point, but then right here, we substituted this back in there, and we could keep these. If you substitute it back, you have to keep these right here. Alright, right there. Alright, the limits of integration right there. Okay, there it is, from 0 to 1, and then you plug the 1 in and you plug the 0 in, and that's really the traditional way of doing it. Okay, that's the way a lot of people have been taught for many years. Again, you still get the same thing. 2 cubed minus 1 cubed still looks the same as what this other side did. Alright, so you keep these the same, provided that when you plug this back in, you have to plug this back into the U. And if you want to keep them the same, that's all well and good. Still gives you the same answer. It's still good. A little bit different here. Maybe, to me, in a sense, maybe easier. I don't know if that, if you know, it may be that you like the other way better. But here's another option anyway. Okay. Let me erase some of this that I wrote where I wrote here. Okay, so again, U is still the same. All of this is still the same. And we still have this U to the 1/2, except now, instead of substituting this back into here, we want to change these numbers here. So from, instead of 0 and 1, we got 4 and 1. Okay. We plugged in the 4. We actually plugged in the 4 up here. 3 times 4 squared plus 1, and got, I'm sorry, it was 1. It was 1. We did plug in the 1, and then that's right. 1, and got 4, and then plugged in the 0 and got 1. Okay, just kind of keep that in mind. And then now you don't have to substitute this back in there, you just leave it as U. Okay. Alright. That, I just felt like, I just wanted to do 2 parts, but I felt like I needed to do this one more time and show both ways of doing it. You pick the way that you like, and if you like the first way better, do that. If you like the second way better, do that. So anyway, those are just, sometimes we just run into different 2 ways, more than one way to do something, and I like to show that sometimes. I just want to show both ways. And if you practice with this, you will get better. It'll get easier for you. It's just what you let, this let statement right here, whatever you let that be, and you had to let it be that because that was under the radical, then that's where you're going to substitute your 0 and your 1 and your 0 in that order. Okay. All right. Once again, this is KP to Math G. Please subscribe. I've got quite a few subscribers now. This is the 61st. This will make the 61st video today. Well, as of now. And I'm just happy to do this. So again, hit the subscribe button, and if you want to make a comment, make a comment. KP the Math G signing off. Have a great day.